ahead and get started on this. So we have two situations, and you're going to be trying to figure out which one's better in what given circumstances. Okay. Now, it's not going to be as simple as most things are in real life, just to say, oh, you know what, this is the better one. Sometimes Al's wages are going to be better. Sometimes Bob's are going to be better. Your job is to kind of figure out, well, when is which one better. Not just to say, oh, this one's the better one or this one's the better one. It's not a right or wrong or, see if you get it. It's a matter of when. So we're going to go through and just make a table for number one. So that X represents the cars sold. So since we have two people, and this is going to be one of the side things we're going to be practicing as well, is labeling everything. So we have two people, so let's label them so we know which is which. And copy instead. Right. We have two tables. Alright, we have cars sold. It says right here, let X represent cars sold. Right? So let's put that here. Cars sold. For both. And it says for Y represents their total pay. So let's look for the Y column for total pay. All right. Total pay. And let's read both of these. It says Al gets $1,000 salary per month, so no matter what, he gets $1,000 base pay. Okay. But he also gets $500 for every car sold. And Bob gets only $250 to start off with. So only every month he gets $250 guaranteed, but then he gets more per car sold. He gets $750. So you can see, like, well, Al's making more money here because he starts off $1,000. Bob starts off $250, but then Bob makes more money per car. So which one is actually better? It's hard just to look at those numbers and realize, oh, it's this one. So let's actually look at these numbers carefully and see what we get. So what number should we use for cars sold? You can't have negative cars, right? You can't sell negative cars, so it makes sense to start at maybe 0 and count up like 1, 2, 3, and 4. See how much they make each at 1, 2, 3, and 4. And since we're comparing these two, we're trying to find out which one's better. Good idea to use the same numbers for both. Now, using Al's information up here, if we don't sell any cars, how much do you get there? So it says up there you get $1,000 salary. So no matter what, if you don't sell any cars, you still have that $1,000 salary. So as long as you show up to work on time and everything, and work every day, even if you don't sell a car, right, you still get that much. Okay. What about here? How much does Bob get guaranteed? Okay. Yeah, only $250. So if you show up every day, you only get $250, which is not a whole lot. I can barely cover food for a month. Right? So let's see how much they make after each car. So Al makes $500 per car. So how much will he make if he sells one car? Okay, so he has the $1,000 he gets anyway, but then the $500 from selling the car. So sell one car, you get $1,000 plus $500. Okay. And if you sell two cars, $2,000. And three cars, $2,500. Four cars, right? Goes up to $3,000. So you can see, since each car you get $500, right? It's going up by $500. So you can see how this right here, how it goes up. This is like the same format that we use for finding slope. So getting $500 per month or $500 per car, that's a slope. Now you want to be thinking that as you're learning math, or somebody else, if they say you're making a car payment of $250 per month, they probably wouldn't say, oh, that's like slope in algebra. But yep, that's where it is. So a lot of people use a lot of this mathematics without even thinking about it. Okay, so what about Bob? So we got 250 to start off with, but we get 750 per car, right? So we go up by 750, right? 250 plus 750 give us 1,000, right? Go up by another 750. We sell another car. 1,750, 1,750. Go up by another 750. We got 2,500. And go up one more time. Another 750. 3,250. So now that we have the tables, we're going to use this to answer a few questions below, but then also to graph it on the back and see which one's better. So you'll be making the same thing just for the next one as well, but it'll just be different numbers and go up by different amounts. But you have to ask yourself, when you're picking these numbers, do they make sense? Like, it makes sense to start at 0 because you can't have negative cars. A lot of the tables we've used in the past have negative numbers too, but here it doesn't make sense to do that. Alright, so let's write an equation for Al. Okay, so let's first go to B and actually figure out the slope, y-intercept, and all that, then we can write the equation. So what is the slope here? What are we increasing by every month? Yeah, it's going up 500, right? And when we were doing this with finding slope, this is only going up 1, we'd say, okay, it's the y's over the x's, that would be 500 over 1, which is 500. So our slope is 500. Okay, and what does that slope mean? I'll just go back to the problem. Okay, Al gets $500 per car. So you can see that the answers to these questions are not something you really have to think really deep about, but just pull it from the information you already know. Per car sold. And if you said the same thing in a different way, it'd be correct. So I'm not going to use the exact words here. But a complete sentence, capitalization, all that stuff is expected. So you can't just put 500 per car. Something like that. And let's do the same thing for the y-intercept. Now the y-intercept is where the equation started. So where did we start here? Started right here at $1,000. So no matter what, we got 1,000 here. Again, what does $1,000 represent? I'll get a $1,000 salary. And now using both of those, remember that our equation, which is a question that was on your test. If it has a slope of 500 and a y-intercept of 1,000, what's the equation of the line? Right, so we're using the same thing we've been learning. Right, so we have our slope, we have a y-intercept. Right, y equals 500x plus 1,000. So it makes sense to do this at the end, really. Figure out the slope, what it means, the y-intercept, what it means, and then you can build the equation. Unless, after a while, you're probably going to be able to read, okay, $1,000 salary per month plus $500 for each car sold, and you'll probably be able to write this directly from there pretty fast. So after a while, you really get used to this. First time through, it'll be everything's new. It won't be as obvious, but after a while, you will get the hang of it. Okay, go ahead and do number 3. Do the same thing that we just did for Al and do it for Bob on number 3. Same exact questions, okay, and they'll be very similar answers, right? So if Al, you might say Bob. Bob gets how much per car sold. Right? So you don't have to come up with a new way of solving or answering a question. Just change the numbers around a little bit. So for the first one, or for the slope, what is the slope for Bob?
Y.
The slope?
Oh.
Oh, no. No, no, no.
Slope goes up $750 per car, right? So Bob makes $750 per car. And the y-intercept? $250, so because he makes a $250 salary. Okay? So you can see the format's very similar for both Al and Bob, right? And now we got the equation, so we got the slope, 750, and then plus 250. So let's take these two equations and go ahead and graph them. Okay. Go ahead and graph them on the back. Now let's write them right above here so we have them. So Al was 500x plus 1,000. And Bob was 750x plus 250. So we're going to graph these both, and we can see when is each person making more money than the other. So here we go. Now, when you're doing this, so we have to use the same information from the table that we do on the graph. Okay. So if you have it here, right, it should be the same on the graph. This is really the same thing represented in two different ways. So for instance, like the X is cars sold, the Y is total pay, right? That just like they told us in the directions here. So when we're doing the graph, we have to use the same exact labels. So I'll make that a little smaller. So let's first start off with graphing the labels. X is going to be cars sold. Y is going to be total pay. Okay. And there's no numbers here, so we have to figure out what to count by, right? So go back to your table and figure out, well, what you count by for the x's. We started at 0, it looks like. We went 0, 1, 2, 3, 4. We could go to 5. But we really only need to graph like 0 through 4, 0 through 5. So that lets you know that you really only need to graph here on the x-axis the same amount. Now, you don't want to do this, like 0, 1, 2, 3, 4, 5, because then your whole graph is only going to be right here. It's going to be all squished in this tiny little part. So go ahead and spread it out instead. And still start at 0, but maybe do like every fourth square count as one car. Okay? So we can go 1, 2, 3, 4. Make that 1, 2, 3, 4, and spread it out. That way we'll get to 5. Okay? And we'll use all of the graph. Okay? We want to use as much of the graph as possible. And the same thing for the y-axis. We have to look at, well, on the table, what do we count by? And we have to come up with a way of counting by numbers. So we can't start at 1 and go 1, 2, 3, 4, because one of the y-intercepts is, what, 1,000, right? So if we start by 1s, we'll never get to 1,000. So look at the y numbers only and figure out what can we count by that will include all of these numbers. We have to include 1,000, 1,500, 2,000. 250, 1,000, 1,750, and so on. We're going to include all those numbers. So what can we count by that will include all of them? Right? Yeah, probably I heard it. Probably counted by 250. So that will include all of them. We go 250, 500, 750, then 1,000, 1,250, then 1,500. Then you'll get 1,750, then you'll get 2,000. So if you count by 250s, that will include all the y values we need to graph. So there's a little bit of thinking here of what should you count by. Number 1, that will include all the numbers, but number 2, that will actually fit up here. So we need to go up to 4,000 or so. So if we count by 250s, it looks like we should be able to get up to 4,000. Start at 250, 500, and patiently write them all out. Nice thing after you do one of them, 250, 500, 750, 1,000, it repeats itself. It just starts off with a 1,000. So it's going to be 1,250 and 1,500. So this it's repetitive. Probably do it just like this in the elephant. The bottom you don't have to space it out by 4, but probably want to space it out at least by 2 or 3. And then we get 2,000. Again, it repeats again. So now it's 2,250. Just take the time, write that all out. Read our graph later on. Took me about 45 seconds. Yep. There you go. So write all that out. Now, the nice thing is, once you've done it, it's done and it's all set up for the rest of the back page. And we can graph these. So I'll give you a second to catch up and write all that down if you haven't already. Okay, so let's go to graph it. Let's do, I kind of color coded it. You won't be able to do that, but we'll label them anyway. Start with Al. Let's do, start at 1,000. So just like we did before, y-intercept of 1,000. And we need to go up 500 over 1. Now remember, we're not counting by 500 like 500 squares. And over 1 doesn't mean over 1 square. So we have to go up 500 and over to 1. Now, if that doesn't make sense, you can always go up the table as well. We need to be at 1 car is 1,500. 2 cars is 2,000. 3 cars is 2,500. Okay, so we can also use that to help us out. So 2 cars should be 2,000. 3 cars, 2,500. And remember, they should line up in an exact straight line. If they don't, something's wrong. And 4 cars. And after a while, you can actually see the pattern here. It's actually up 2 squares over 4. And you could use that. Up 2 squares over 4. And then go ahead and do the same thing for Bob. And again, if you're not sure where to start, just remember it's the same exact as the table. 0, 250, start at 250, 1, comma 1,000, 2, comma 1,750. Or we could just use the y-intercept, same thing, 250. 1 car, you'll make 1,000. Right? So it's a different slope, going up faster. 2 cars is 1,750. So 2 cars, 1,750. 3 cars, then it ends up at 2,500. They overlap. And you can use the slope if you want at this point. You can see how many squares up and over you have to do. So go up 1, 2, 3. Over 1, 2, 3, 4. Up 3 over 4. So we can do that. Up 3 over 4. Up 3 over 4. Now, technically, this is good for our graph. We don't really have to connect it because there's really no anything between 1 cars and 2 cars doesn't have a real meaning. Meaning you can't sell 1.5 cars or 1.75 cars. So it doesn't really make sense to draw a line. But for the purposes of us just seeing who is making more money and when, it does help. So I'm going to draw the line just for that reason. But normally we want it just because it doesn't make sense entirely because there's no fractions of cars in between. Okay? But when you draw the line, you can see a little more clearly what's going on. Right? You can see who's making more money and when. And since we have 2 lines on there, just so it's not confusing later, let's do labels. So this is Al, and this is Bob. So we can see who's making more money and when. So label those lines. So this is everything that you should have on your graph. It's a lot of information, but it's not that difficult. It might take a little while to get everything on there. Okay? But yes, you on your quizzes and your test for this, you get a point for having the labels correct. You get a point for having the scale on the X correct and scale for the Y correct. So if you're like, well, I don't feel like writing it out, just know that does count towards something. It's not, you can't just leave things off and say, it's good enough for me. And you want anybody to be able to pick up your graph and understand what's going on. So if you don't have the labels there, they won't know, like, well, what do these numbers stand for? They need to have that car sold label so they understand, oh, this is how many cars we sold. Okay? So the next thing it asks is how many cars would Al and Bob have sold? How many cars would Al and Bob have to sell for them to have the same? Okay. So yeah, basically, where do they intersect? Yeah. So right here where they intersect, right? After 3 cars, they make the same amount. So if you happen to sell only 3 cars, it wouldn't matter where you worked, you get the same amount of money. So we can say after 3 cars sold, they make and let's go down to 5. What would Al's pay be if he sold 5 cars? So since we have the right, so we can follow 5 cars all the way up to Al. You can see it right there. It intersects at 3,500. $3,500. And same thing for Bob. What would Bob make after 5 cars? So let's go a little higher up to here, right? And we'll go all the way over. Yeah, 4,000. Bob would make 4,000. And please use complete sentences. Don't just put 4,000, but put Bob would make $4,000. Just by going off the graph, whoever's above, whoever's on the top, that's who's making more money. And so, who pays more money? And this is where you have to be careful. What if you only sold 1 car? Who makes more money? Al. So it's when you hear this question, you don't want to be thinking, oh, it's one of the two. One of the two is going to be the correct answer. Not really. It really depends on, well, how many cars do you sell? So from here to here, right, all the way here to here, which is from 0, 1, 2, or 3 cars, right, Alice pays more money. But then once you get above 3 cars, right, from here, right, 3 or more, that's when Bob pays more money. So it's about thinking about, in real life, you'd be thinking, well, which one is there's one lot that's bigger than the other? Like maybe if Bob's lot is really small and they only have like 15 cars for sale, it might be a lot harder to sell a car. So even though they make $750 per car, it's harder to sell it, so maybe not as good as this. So there's other variables and things to think about than just the money. You know, how easy is it to sell a car? If you're working at a dealership that has thousands and thousands of cars, they have every color and every model of everything, probably more likely to sell more cars there. So some other things to think about usually is not just pay. You don't just think about just the pay and who makes more money. You'll come across the same thing as, you know, working at a store in the mall or working at a restaurant. A store in the mall might make $15 an hour, but a restaurant maybe only pays $12 an hour. So which one should you work for? make more money? Probably the store, but then you forget that, well, if you're working at a restaurant, you probably get tips. So if you get $100 of tips every night, even though the store makes more money, the $100 tips make it worth it to work at the restaurant. So you got to think about more than just how much do you get paid every hour, because there's other things that you can get paid for than just the hourly wages. You can have salary or you can have tips. Okay, a lot of other factors. So going back down to here, that's what you want to consider. Yeah, for 0 to 3 cars sold, yeah, Al makes more money, but then for 3 or more cars sold, that's when Bob makes more money. And down here you can just explain in words because, you know, Al makes more money for 0 to 3 cars sold. But Bob makes more for 3 or more cars. And you can word it however you want. This isn't the right way of saying it. There's many ways of saying, yeah, from here to here, this person makes more, but from here to here, this person makes more. Okay, so whatever verbiage you want to use, go ahead and use that. So something like that, right? Now, what I want you to do now is to start and finish the next problem. Go ahead and disconnect the 2 pages. Take the staple, just take it out or just take it apart, and put these side by side. So as you're doing this, right, with the frozen task, it's very similar, right? You're still going to make tables and everything, but in case you get stuck, you'll have the example right there next to it, and you can easily see, like, okay, how do we just do it and make it look very similar, okay? So the 2 will look very similar to each other. One is not more difficult than the other, so we could have done these in either order. It's not like it would have changed anything, but use the example to really help you finish the next one, okay? For today, you're really just going to mirror what we've already done, and then tomorrow we'll get more in depth on some other things, okay? All right, so your goal is to finish this in the next 15 minutes, okay? So finish the next problem all